Our last topic, believe it or not, is going to cover parallel and perpendicular lines, which you guys should have heard of when you were taking some kind of geometry at some point in your younger days. And if you don't remember, parallel lines are basically lines that never touch but travel the same. Whereas perpendicular lines, in case you don't remember, those are lines that make a 90-degree angle where they cross. So if you look at these two lines on this graph, you can see at the point where they intersect, makes 90 degrees. So we call them perpendicular lines. That'll be important when you guys take college prep geometry. So really quick, we want to count the slopes of the two lines below. So it looks like for the first line, we are traveling up 3 spaces and over 1. And for the second line, it looks like we are going to travel 3 spaces again and over 1. And if I look at the slopes for the perpendicular line, we'll do this one first. Looks like we're going to go down 3 and over 1. And if I look at the other line, it looks like we're going to go up 1 and over 3. So you're supposed to notice something about these slopes. So let's look at the parallel ones first. Obviously, they're the same slope, and that's kind of the gist of what we're doing. Anytime lines are parallel, their slopes will be the same. And if you have two lines that are perpendicular, their slopes will be like opposite of each other, so a negative and a positive, and they'll be flipped. So 3 is the top and 1's the bottom. The other slope will be 1 on top, 3 on the bottom, and that will always happen. So that's what we're going to write down. Parallel lines will have same slopes, and perpendicular lines have slopes that are flipped and opposite signs. So the sign will change and the fraction will flip. And if this happens, the fancy term that we use will be opposite reciprocals. So that could be 3/5 turning into -5/3. I could have 4, which will reverse to 1 over 4. Sorry, -1 over 4. I could have -4/9, and that will reverse to +9/4. So if these were slopes of two lines, they would be perpendicular because of what they're doing. So we are going to practice writing equations of parallel and perpendicular lines. This is the setup that I like to use, and my kids found this very successful in the past. We will record our current slope. We will use our parallel lines to write down our new slope. So we'll use the rule about parallel slopes. And then I will always provide you with a point to use. It will be as an ordered pair. So right now, my current slope is 3. My new slope of this new parallel line will still be 3 because parallel lines have the same slope. And the point you are to use for this equation is 4, 1. Once you have done that, this does not matter anymore. This is the info you use. And if you haven't guessed already, it's going to be a case 2 problem. 3 goes in the middle, 1 will go front, and 4 goes in the back. Now I'm going to pause the video and solve this equation, as you should, and then you can check your answer with me when you're done. You should have gotten 3x minus 11. In example 2, we are going to write the equation of a line that is perpendicular to this line, and our new line will contain that point. So I will go ahead and write 3, 5 as the point you are to use. Your current slope is 3. But because this is a perpendicular line, your new slope will be flipped and opposite. So I am now done with this. Don't need that anymore. This is the info that I need to write my linear equation. So negative 1/3 will go in the middle, 3 at the end, and 5 at the beginning. And once again, I'm going to pause the video and work the problem out. And when you're done, you may unpause and see if your answer matches mine. Hopefully you got y equals negative 1/3 x plus 6. Or instead, you could write negative x thirds plus 6. Both are the same answer. Both would be accepted. So what I'm going to do now is I'm going to pause my video one more time. I'm going to erase all this mess, and I'm going to draw you a picture of what you just did so that you can make the connection between your work versus a picture. What I've gone ahead and done is I've plotted our original linear equations, meaning if you were to graph this line for me, it would look like this. It would start at 2, and we would travel up 3 over 1. And obviously, this will be the same graph because that's the same line. So I just graphed both lines for us. What we're going to do is tackle the problem for which we were asked to complete. So you're supposed to find a line that goes through that point. If I plot for 1, it's right here. I'm going to draw a line that's parallel so that it goes through that point. Your mission was to find the equation of the green line. After doing all of our work, we got 3x minus 11. And that seems to make sense with the picture. It looks like it might cross down here at 11. And sure, it could be going up 3 over 1 each time. So it kind of makes logical sense. If you got plus 30, then you know you made a mistake, because positive 30 is way up here. If I graph my perpendicular line, it must go through 3, 5. So I will plot 3, 5. And again, perpendicular basically has to make 90 degrees. So you got to draw a line that makes 90 degrees with the other line. What you just did with all your work is you actually found the formula that goes to this green line. And our formula seems to make sense. It looks like it might pass at a positive 6, and it's definitely going downhill. So that seems to agree with what we've graphed. So in our example problems, I'm going to help you figure out what goes in your blanks, and then I'm going to let you guys solve it on your own and check your answer. So the keyword here is parallel, hence same slope. And right now my slope is 5/2. And my new slope will still be 5/2. The point at which your line will go through is -4, 3. I'm going to jump over to example 4. This time we are focusing on the word perpendicular. Our current slope is 2/7. Our new slope will be flipped and opposite. Last but not least, the point that you are supposed to use will be 10, -3. We'll go ahead and fill in our blanks as a case 2. And again, at this point, it's review, so I will let you solve it on your own, and I will as well, and then you can check your answers. So take a look at my answers, and hopefully you got the same answers. Keep in mind that when you have a double negative, you need to convert that to a double positive. And the same thing over here. If you have a double negative, you want to make that a positive. And when you multiply a negative times a negative, you get a positive. So check your signs if you don't have these answers and see if your mistake was with that. The last 2 examples I'd like you to do completely on your own. So you're going to pause this video, and when you unpause, you'll see my work and my answers on. Your first answer should be 5x minus 20. And your second answer should be 3/5 x minus 7. If you got those right, good job. If not, take a look at my work and see if you can find your mistake. Keep in mind, when it comes to perpendicular problems, crossing out the current slope is really important. There's a lot of kids that go back and they use the current slope instead of using the new corrected slope. If you cross this out, then all you can see will be this information, and that's what you want to use.